degrees. Okay, so those are our triangle ones that you should know. And then the last three that I have are the parallel line theorems. So these last three, the corresponding angles, alternate angles, and co-interior angles, have to have parallel lines. So I'm going to write that in here, parallel lines. These ones only work with parallel lines. You have to have that. I'll put the parallel lines in on the other page in a moment. Okay, and sometimes we call these like F patterns or Z patterns or C patterns, and I'll show you what that looks like in a moment here. What we need is a pair of parallel lines. So I'm going to make two lines parallel to one another, and we know that they're parallel by the fact that we have these arrowheads on the lines. That means that this one's parallel to this one. So that's what tells us that. And then I'm going to draw a transversal. Trans just means to cross. So I'm drawing a line that's crossing over my parallel lines. Now when I'm talking about corresponding angles are angles at corresponding positions in our diagram, and they're going to be equal to each other. So corresponding position means we have the same side of the transversal. So I might choose for this transversal here, I could go to the right of it, and it has to be on the same side of the parallel line. So if I choose to be to the right of my transversal and below the parallel line, that would make this angle in here, and that angle would be equivalent to the same thing that happens lower, to the right of the transversal and below the parallel line. So this angle right here is going to equal the one we have up above. So let's mark that in. If I call this one letter A, then this also will be equivalent to it. I'm also going to call it a letter A. So that's the angle there and there, just underneath and to the right. Underneath the parallel line and to the right of the transversal. Now, something else that you may have talked about, and I'm going to see if I can change things up a little bit here, is this one is what we look for in terms of a pattern, an F pattern, a capital letter F. If you notice, I'm going to trace part of my transversal, and then I'm going to trace my two parallel lines. These angles are both in this underneath the, to the right of the stem of the letter F. So here's the stem, or to the right of the stem and below the lines that come out from the letter F. So we're in the same position. I could also, let me just see if I can change to a different color altogether. I could also trace F's in other positions. It doesn't have to face the correct way. I could change, I'm hoping you can see the yellow here, I could change my F to be upside down. So my F is here. I'm going to go to the left this time, and underneath the two parts of the F, these two angles would equal each other. They're on the corresponding positions, both to the left and both above the parallel lines. So hopefully that helps you understand what corresponding angles are. Let's see if I can tidy that up a little bit. So there we are. So you might want to add in here that this is the F pattern that we're looking for. Okay, we're really looking for that F pattern. The alternate angle, we also call that one following a letter, and it follows the letter Z. Okay, where our top and our bottom of our Z would be our parallel line, and then the part that joins the two parallel lines together is the transversal. So if I draw this in to my diagram here, let's do a pair of parallel lines, mark them parallel, draw a transversal, and I'm looking for my letter Z. I'm going to trace one in a minute. The theorem says that angles between the parallel lines, so we're going to be inside the parallel lines, and on opposite sides of the transversal, they will equal each other. So what I'm looking at here is if I'm inside my parallel lines, between the parallel lines, I'm looking at this and this. Those two would be equal to each other. A would equal A here. So in the crooks, I call them the crooks of the Z. Those two things are equal to each other, those two angles. Similarly, I could trace out a Z backwards. So I'm going to use my yellow here again. Let's try this. I could actually trace out a Z backwards. Okay, using my parallel lines as my top and my bottom. In the crook of the Z, I'll call that B. That angle and the one down here for the crook of the Z is also the same as each other. All right, so we're looking for those kinds of letters, the F and then the Z. And those angles are equal to each other, corresponding angles and alternate angles. Sliding over the back side of the page, we've got co-interior angles now. Co-interior, co means to work together, interior means inside. This pattern is the one that we call a C pattern. Okay, so I'm going to try and draw this in here. A C pattern, we have our parallel lines. This time, instead of extending that and making it into the F, we are going to look between the parallel lines. And it's not that these two angles are going to be equal to each other. The angles between the parallel lines, and on the same side of the transversal are going to add to 180 degrees. All right, so let's draw parallel lines. Parallel line, here's my transversal. They're not equal to each other, so I'm not going to label them both A's or both B's. I'm going to label one an A and one a B. And when they're on the same side of your transversal, so in this case they're on the right side of the transversal and they're in between my parallel lines, those are going to add A plus B equal 180 degrees when we add them together. So that can help us solve for some unknown angles. Now we're going to use theorems to help us find the marked angles, the unknown marked angles. Write the values in the order you found them along with a theorem you used to help you find them. So here's our example we're going to work together. Now I do have arrows on my diagram here and here, so that tells me that these two lines, this one and this one, are parallel. So from that, I'm going to see if I can come up with F patterns or Z patterns or some C patterns. Now since I have these two lines kind of cutting across, I'm thinking I probably am going to come up with a Z pattern here. So if you look, turn it sideways, you see I have a Z. I know the angle in the crook down here at the bottom is 75 degrees. If I match that up, that tells me that angle A has to equal 75 degrees. Those are equal angles. Those were alternate angles. So here's my reason, the theorem that I'm using, alternate. Let's spell that correctly, Logan. Undo. Alternate angles. And here's my short form for angle, so I don't have to write it out. So A is equal to that. Now, the next thing I'm noticing, now that I know A is 75 degrees, I'm noticing I have a little triangle here. And I know that the angles inside of a triangle have to add up to 180. So that means my angle B would equal 180 degrees. Take off the 20-degree angle and take off the 75-degree angle. So I got to do some mental math here, or you can use your calculator. 180 take off 75 would be 105. If I have 105 and I take off 20, I believe that will take us down. So 105 take off 20, well, take off 5 would take us to 100, but now I need another 15. 100 off of 50 would be 85. So that's going to equal 85 degrees there. But again, use your calculator. And that's because angles in a triangle add to 180 degrees. So we use that theorem, the sum of the angles in a triangle. All right, so I've got B now is 85 degrees. Now, let's see what else I've got here. Change some color. All right, looking at my diagram, I need to get C and I need to get D. And again, you don't have to do them in letter order. I could do D next. I'm thinking if I use my parallel lines here, and if I were to go like this and trace out a Z this way with my parallel lines, that D would equal 20 degrees. I could have even started with D. Okay, I didn't have to start with it, so or I didn't have to wait till the third move to get that one. I'm going to put my D equals 20 degrees in there, and that was through alternate angles. It's not the only way to get that one. I could have found C first and then gotten D through the angles in the triangle, add to 180 degrees. And I could get C now by using the angles in a triangle, add to 180 degrees. But I'm going to be a little quicker with that one. I notice that I have two lines that intersect each other. This reminds me of my vertically opposite angles here. So that tells me the two angles across from each other in my diagram have to equal each other. So angle C will equal the same as angle B, which is 85 degrees here.